Hi, I'm Jamie Patton, State Agronomist with Wisconsin NRCS, and I'm going to provide us updates today on the 590 update process, changes to the soil map units within Web Soil Survey across the state starting on October 1st, as well as clarifying what is contour farming. So briefly, where are we at in the 590 update process? As many of you know, the current Wisconsin 590 standard was published in 2015. In 2019, National NRCS came up with a new standard, and we have yet to update our standard to meet those new requirements. So we're in that process right now. Going through what is called a SOC process to get that updated. If you haven't seen the current FIT 2015 standard, you can find it here at this website, which is on our Electronic Field Office Technical Guide, or ePhotog, for the state of Wisconsin. So I mentioned the SOC committee. When we update a standard such as 590, because it has large implications across the state, we go through this 6-step process, which is led by the Wisconsin Land and Water. So we identify a team to work on this. We have a team of approximately 12 individuals that make up agency, university, as well as private industry and nonprofit folks who are working together to come up with a draft standard. So we have that complete. We have also completed our first draft standard, and where we are at right now is that draft standard is out for internal review. So it has been sent to approximately 8 to 10 individuals across the state, and they're providing individual comments on our draft standard. We will review those comments, address those comments, and come up with a new draft standard. And what you're more interested in is when we get to step 4 and 5, which is conduct a broad public review and then come up with that finalized standard. We expect a draft standard to go out for general public review sometime within early to mid-October. There will be a 3-week comment period, and all interested parties across the state of Wisconsin are invited and welcome to comment on the new draft standard. The draft standard will be posted on the SOC committee website, so socwisconsin.org. It will be in standards and development, and it will actually appear down here under anticipated broad review. There will be notices, email notices, as well as news notices sent out when the draft standard is out for public review to invite comments from everyone. And what we're looking for is our comments that will help us ensure that this standard not only meets our nutrient management requirements across the state, but also make sure that this standard is applicable and implementable across the state. So the general proposed changes, what you're going to notice when you do see the new draft standard is it is written in a different format primarily. While the content is very, very similar, it's organized differently to better match the new national standard. We also work to outline soil and manure and organic byproduct testing and crediting to ensure that that is being done consistently across the state and is providing us the best information we can to develop nutrient management plans. You'll also notice that our current N-restricted soil requirements, as well as our soil test phosphorus and phosphorus index requirements, are reformatted and reorganized into an NRCS framework entitled Nutrient Loss Risk Assessment. So the content is very similar. Again, it's just reformatted to meet the new national standards, and it'll be located very close to the beginning of the document. So make sure you pay attention to those and make sure that they're understandable and implementable across the state. You'll also notice that much of the information is going to be reorganized into the 4R categories: right rate, right time, right place, right source. So same information, again, just reorganized. We work to simplify winter spreading and the requirements and where that applies and how that would be done across the landscape. And we work to clarify the requirements for N-restricted soils as well as SWCMA application strategies. So those are 5 of the big changes that are going to occur potentially once we get through internal review within the draft standard that goes out for public review. And so I'm just trying to highlight topics that you may want to pay attention to as you're going through the new draft standard and making your own comments. So again, we hope to have that out for general public comment mid-October, and there'll be news notifications when it's available and when and how to comment. The other update that I have is the soil map unit updates. So each year on October 1st, NRCS updates its soils data. This year there's going to be a significant change, at least for the eastern side of the state. So in 2006, the western side of a state went to a soil map unit nomenclature that was a numeric alphanumeric nomenclature. The eastern side of the state is still using an alphanumeric nomenclature. So for example, I just popped up Manitowoc County. You'll notice that Boyer Sandy Loam is represented by BR. So letters, and then C2, which are again letters and numbers. What we're going to be seeing that to, and I don't have the crosswalk just yet, is all of our map unit symbols are going to be a numeric alphanumeric system, where that first number represents the soil, the letter in between represents the slope class, and the last number, if it is present, indicates an erosional class. So it's a way to standardize the soil map units across the state, to update them across the state, and to provide general consistency on how we're naming soils. This is primarily, particularly for those of you, it's going to be important for those of you who are working in multiple counties across the state and are flipping back and forth between these two nomenclature type systems. So again, we're going to this new system where the first number will be the soil type. In this example, you'll notice the 175B2 is the Paulsgrove silt loam, so the 175 represents the Paulsgrove. The letter, so that B is the slope class. So you'll notice prior to this standardization, oftentimes these letter slope classes had wide ranges. So for example, sometimes in some soil map units, an A meant 0 to 1, sometimes it meant 0 to 2% slope, sometimes it meant 0 to 3% slope. So the idea here with a standardized nomenclature is to make it consistent across the state, which aids in interpretation. So we have those new slope groups that are being listed here, and that ending number is based upon erosion class. So in very simple terms, it's based upon how much topsoil remains within that soil profile. So if most of the topsoil remains, then that doesn't have a number at the end, meaning that it has only it's either depositional landscape position or there's only slight erosion occurring on that landscape position. A 2 means that it's moderately eroded, so that is a decent portion of that topsoil has been eroded off the landscape, and the topsoil depth is shallower than what it would be in the standard reference for that soil. And 3 means it's severely eroded, so that a majority of that topsoil has been eroded off that particular soil, and the topsoil depth is much shallower than the standard reference soil. So again, consistency. First number is the soil. Letter is a slope class. Last number, if it is present, gives us an idea of the amount of erosion that has occurred on that landscape position and then that soil type. In addition, the numbers mean something. So when we look at that first number, the soil number, here is a key to those. So for example, if you would see a number less than 100, you will automatically know that that is probably a peaty or mucky soil, an organic soil. You'll notice anything in the 700s is an alluvial soil, subject to flooding in central Wisconsin. You know, anything in the 6,000 level is going to Wisconsin and age glaciated soil managed by the Duluth Soil Survey Office. So the numbers will have a meeting and they're going to group those soils together based upon parent materials. Oftentimes, and in particular, I'm going to concentrate on those in the green, which are going to make up a majority of our state. Those numbers further are refined by that the last number indicates the drainage class of that soil. So if it ends in a 0 to 5, we know that it's excessively to well drained. 6 or 7 means it's moderately well drained. 8, somewhat poorly drained, or 9, poorly to very poorly drained. So let's look at some examples of this. So for example, 118, which is a ceton. A ceton, so the 118, because it is in that 100 range, means that it's a thin to thick loess underlying limestone or dolostone bedrock. So we know immediately something about that soil because of the number range in which it's in. In addition, we look at the 8 at the end, and that 8 is going to tell us that it is a somewhat poorly drained soil. Another example, the 811, which is the Plainfield soil. 800 series means it's underlain by Illinois and Till. And the 1 at the very end means that it is excessively to well drained. So as we get more familiar with this new nomenclature that is being used, I think it's going to be really useful as we start to screen some of those soil map units just by their symbols, and we're going to be able to tell a lot about that soil without even reading the description of it, because of this new standardized naming system that we'll be implementing across the state beginning on October 1. And last but not least, my update on contour farming. So there's been a lot of misunderstanding of what is and is not contour farming. So I want to give an update from the NRCS standpoint what we consider to be contour farming. And why this is important is that there is a checkbox in SNAP Plus version 2 as well as SNAP Plus version 3 for on the contour or not on the contour. So what do we consider to be on the contour? Well, we're going to go back to ePhotog and we can look at the contour farming practice standard. You'll notice in general, it's talking about with contour farming is the direction of water flow is going to be around the hill slope. So not down the hill slope, but instead around the hill slope, along, as the name says, along the contour or the topo line. So the first thing we have to do is define the difference between slope and row grade, because we're going to talk a lot about row grade, and it is very different than the slope of the land surface. So I'm giving you a hillshade map here. You'll notice I put a little blue ovoid on this map. So for example, if a raindrop hit within that blue oval, right, we would expect it to move down slope, right? It would move down across the topo lines and end up in that lower flat area at the bottom. That is considered the slope. So if there was no vegetation or no intervention by humans through agricultural practices, a raindrop that hit that land surface would move downhill. And when we measure the slope of the land, this would be the slope. Row grade, however, is if we manipulate this landscape, right, with contour farming, and we would move have that water move laterally across the hill slope to a safe outlet to a grass waterway, we essentially shorten the length of that slope, right, which decreases the energy and decreases the erosivity of that water, and we also make the steepness of that water grade much lower. So instead of running all the way down that steep hill slope, it's going to move at a shallow slope across that contour and into a safe outlet. So the whole idea of contour farming is to shorten the length of the slope as well as to lessen the steepness of that slope, thereby reducing the energy of that runoff water and thereby reducing the erosive process of that runoff water. So why we need to understand that is when we get into that practice standard, you'll notice that by definition, the row grade should be aligned as closely as possible to the contour. So that topographic map where we have those lines drawn on that map indicating it's the same elevation across the hill slope, that is the direction that we should be doing our field operations on the contour. There are some caveats because obviously hill slopes are undulating. There's some challenges with field shape, so on and so forth. So you'll notice by the standard NRCS standard, the maximum row grade can only be half of the slope of the hillside or up to a maximum of 4%. But in general, what we're going to see is that we would prefer, right, if the soils have ponding potential, we need them to be over 0.2, and if infiltration is our primary purpose of this practice, we would like that row grade to be as close to 0.2 as possible. So when we think about these numbers in general, right, contour farming, in general, we want that row grade to be somewhere near 0.2 or as close to contour as possible, because if it's on true contour, it would be 0. But we want it to be as close to contour as possible. 0.2 allows for water movement and lack of ponding on the landscape. But because of field shapes, we will, depending on the situation, the standard allows for up to 1/2 of the field slope or 4%. Whichever is greatest. Okay. But in general, I know that's a lot of information. In general, it should be as close to the contour as possible. You'll notice within the standard, if you read through it, there are slope lengths, again, to reduce the energy associated with that runoff water. But what I've highlighted here is that surface water flow from the field must be in a stable outlet. So in the picture on the right, you'll notice we have that flatter hilltop, which is located at the bottom left-hand corner of the picture, and you'll notice the field is on the contour, and those contours are feeding into grass waterways. So following those topographic lines as closely as possible and dropping that water into a safe outlet. Those are the key features of contour farming. Okay, just to visualize this, right? We want those field operations to be as close to the contour as possible. Realizing the picture on the right-hand side has some terraces in play as well, but you'll notice all of those field operations are pretty much on the topographic lines itself. So these are pretty good examples that we could just look at them visually and we'd say, yes, they are on the contour. There are other situations out there in the landscape that do not meet contouring, right? So what is the impact? So when we look at these pictures, we need to think about the LS factor is the length and the steepness of the slope. Are these practices shortening the slope length, and are they making the grade or the slope less? And you'll notice in this picture, while the upper left-hand corner, we may have some of our field operations going along that hill slope, you'll notice much of what we're looking at straight on is up and down the hill. That would not be considered on the contour. This aerial photograph of another field, you'll notice all of the field operations. You can see the upper flat surface where the slope is not all that great, and so it's not necessarily following what we on the contour because there isn't a contour up there. It's flat, but as we start to go around that hill slope, you'll notice they're following along the contour and they're dropping that water into safe outlets that are vegetated. Same here. Is it on the contour? You'll notice the field closest to us looks like it's probably those field operations are perpendicular to water flow or parallel with the contour lines. But as you go through the rest of the field, you can notice those field operations are up and down the hills. So no, not on the contour. Another aerial photo, yes, on the contour. You'll notice they're following those topographic lines quite well. And wherever water is exiting or concentrating, there is a safe channel for that water flow. So hopefully this gives you a little bit better idea of what is actually expected on the contour. We are expecting, if you check that on the contour box, that field operations are as close to those topographic lines or as close to contour as possible. There is a little bit of leeway if we get into measuring those slopes. Again, maximum road grade would be up to 4%. Or 1/2 the slope of that hill slope. But ideally, like I said, in the most simple terms, we're looking at it to be as close to 0.2 or as close to 0 on contour as possible. So it's a pretty easy, if your contours were designed by a land conservation professional, so NRCS, your county professionals, someone else, an engineer, and no matter when they were laid out, how many years ago, and those contours are still being followed, it is a very simple yes, you are on the contour. Many of us are designing these field operations on our own. So when we look at our field operations, are we drawing those contour lines with our field operations? Are our road grades as close to 0 as possible for our field shape and our field size and our field topography? If we are essentially drawing contour lines with our field operations and water is safely exiting the field, even though it may not have been designed by a conservation professional, we would check on the contour. However, if it does not meet those requirements, it would not be considered on the contour, and we should not check that box in SNAP Plus. If you have any questions about what is and is not on the contour, I encourage you to reach out to our nutrient management professionals in DATCAP or to reach out to your local land conservation department, extension, and or the NRCS. Thanks.